Hello everyone, welcome to today's session. Today we will try to build Azure AI Language Service NLP CLU solution. This is the new solution we want to explore in this session. Let's get started. As usual, we log into the Azure AI service. We go to the language service here, and today we will create a language understanding model with the language service. The AI language service enables you to define a conversational language understanding model that applications can use to leverage the natural language input from users, predict the user's intent, what they want to achieve, and identify any entities to which the intent should be applied. For example, a conversational language model for a clock application might be expected to process inputs such as, what is the time in London? This kind of input is an example of utterance, something a user might say or type, for which the desired intent is to get time in a specific location, an entity, in this case, London. The task of a conversational language model is to predict the user's intent and identify any entities to which the intent applies. It is not the job of a conversational language model to actually perform the actions required to satisfy the intent. For example, a clock application can use a conversational language model to understand and to intellect that user wants to know the time in London. The current application itself must be implement the logic to determine the correct time and present it to the user. So firstly, for this kind of task, we need to provision an Azure AI language resources. So we locate to the language service here. We click create. Continue to create your resource. Resource group, I create a new resource group called AI. Keep the region East US. User 1001, test 1001 as the username. 102. And read here. We select review and create. After run the file validation, we will create the resources. Do remember in our last session, we shared about the configuration for language resources, how to do it. We need to create a project and configure it there. So you will locate into another studio called the Language Studio, and this kind of a service will become combined into the Azure AI Studio later. Let's take a moment for the deployment. Today, after create the project, we will create the intents. We will label each intent with sample utterance, and we will train and test the model and entities. After that, we will retrain the model and use the model from a current app. So this is a very interesting walkthrough for today. Let's pay attention. or what will be set up for today. It will be very, very interesting. Okay, the resource is already deployed. So let's kickstart our journey. We'll move to the language studio here. I have already logged in. I will select the subscription. Language type is language. The resource name, we select the resource we already built and click done. Now, we are ready to create a project, create a conversational language understanding project. Let's create new conversational language understanding. So our name here, we type clock. Keep primary language as English and description, natural language clock. We review and finish. So the first task is about create intent. In the schema definition page, on the intent, we select add. To add a new intent here, and the name will be get timed because we will get the time later on. We continue to get the day and continue to get the date. Cool. So the last one, we try to label the intent. So we select the labeling here, and we select get type, and we type what is the type. And we add another one. What type is it? What's the time? What type is it? Tell me the time. Perfect. We have add 4 new utterance. We write the utterance in the text box next to the intent and then press enter. So we will have the input there. The last one, we select get date. We repeat the same. What day is it? What is the day? What is the day today? What day of the week is it? The last one is get date. What date is it? What is the date? What is the date today? What is today's date? What is the date? What is today's date? After we add all of them, remember, we need to click Save Changes. Now, after save the changes, we are ready to train and test the model. So we'll go to the training job. Here, we will start a training job. and select the option to train a new model. We enter the name called Croc, and we select standard training, which is for free, and the default speeding. And we select train. We wait for the data to be complete. You see the training already been completed, the evaluation is currently starting. Later on, we will add the entity like the learned entity, list entity, and so on, and retrain the model. So this is the first time we train the model. Okay, the training succeed, and we are allowed to move forward. We are now ready to move forward. So we click the training job and check it, all good. We select model performance and click the crop model. Review it, and we select deploying a model and select add new deployment, and deployment name we select we type production, and select the crop model in the model field. This is our training model, and we select deployed. The deployment may take some time. The model has been deployed. So we select testing deployments, and we select the production deployment, and we try to enter something. For example, right now I will type, what is the timeout? We run the test. What is time now? We get time, get day, get the result. And we clear the test box, and we type something like tell me the time, and we run the test. We will the predicted intent and confidence score, and we type another one. We clear test box, we type another one. What's the day today? We run the test. Hopefully the model predict the get day intent. So the next one is we try to add entities. So far, we have defined some simple utterance that map to intent. Most real applications include more complex utterance from which specific data entries must be extracted to get more context for the intent. So let's get started to add a learned entity. The most common kind of entity is a learned entity, in which the model learns to identify entity values based on examples. In the Language Studio, we return to the schema definition, and we click entity, and we click the add button to add a new entity, and we type location, and ensure learned is selected. Okay. Add entity. After the location entity has been created, so we will return to the labeling page, data labeling page, and we select get time. And enter foreign new example. What time is it in London? You see here, what time is it in London? Select the word London, and in the drop-down menu, select location to indicate that London is an example of location. Okay. Let's do it again. Get time. Again, what time is it in London? Add it first. Select London. Location. To label location to indicate that London is an example of location. And another example is get time. So we type, tell me the time in Paris. We add this example again. We highlight the word Paris to highlight it is made to the location entity. We add another one. What is the time in New York? It's not New York. And map it to the location entity. Now I'm able to save changes. We select save changes to save the new utterance. Perfect. We now add a list entity. In some cases, valid values for an entity can be restricted to a list of specific terms, which can be held the app identify instance of the entity in utterance. So in the Language Studio, we return to the schema definition, and then on the entity tab, we add. Now we add another entity. The entity name is weekday. Make sure this time we select list, not learned. Okay, select list and add entity. On the page of weekday entity, in the learned section, ensure not required is selected. Then in the list section, we select add a new list and enter the value Sunday. Some. Save the changes to make sure it is displayed directly. So we add others. Sunday, what's next? Monday, right? Monday. Save. Tuesday. Save. Wednesday. Save. Thursday. Save. Friday. Save. The last one's Saturday. Save. After adding and save the list value, we already saved it, right? So it is already there. Right now, we can go to the data labeling. And from here, we select the get date. And we type what date was it on Saturday. We highlight Saturday. Just type it firstly. We highlight Saturday as the weekday. We do another example. What day will be on Friday? Action. And we select Friday as weekday. Make Friday to the weekday entity. Do another one. What will the day on Thursday? And we select Thursday as the weekday entity. Remember, we save the changes. Now, it is so interesting right now. We already add the label for location and weekday. The next one is add a pre-built entity. The Azure AI language service provides a set of pre-built entities that are commonly used in conversational applications. In the Language Studio, return to the schema definition. And right now, we go to the entity and add a new entity. And this time, we type date and select the pre-built entity section and add entity. The pre-built component allows you to select from a library of ready pre-built common types such as numbers, date type, names, and when added, a pre-built component is automatically detected. Let's add it. Now we have already added, right? So what's next? This page of date. We scroll down to the preview entity tab, right? We select a preview, date and time, date time. We click save. And after adding the preview entity, return to the data labeling page, and we select get date. And enter the following example. What day was January 1st, 1901. We just add it. We select this one, select the date, and we select it is about date. We add another example is what day will be on December 31st, 2099. We select here and select it is mapping to the date entity. We save the changes. We can select the save changes to save the new attachments. Now we are ready to retrain the model. How to retrain the model? Remember, we go to the training jobs here. We start a new training job. And select override an existing model, which is clock. We override and train it. It is so interesting because we are not doing the new one, but we are overriding an existing model and try to improve it, perfect it. So later on, we can select the model performance. We can review it, right? Do remember next is model performance, deploy the model test deployment. This session is so interesting and so comprehensive. After the learning, you have already learned how to use the Azure AI language model and all the functions in the UI. You have tested all of them. So it's very useful in this session. Now we see the training is already complete and the evaluation is in the progress. Good. Code training completed. Now we are ready to go to the model performance. We click the preview and see the training are trained successfully. Right now we are ready to deploy a model. We add new deployment and override an existing deployment, which is production. And the model, we select the crop model and we select deployed. It may take some time. And do remember, after deployment is completed, we'll go to testing deployments. Now it is completed. We test the deployment. We select the deployment lay is production. We try to ask some question there to see whether it can return something right. So he know it is a location, and this is good. So we try another one. It's about what time is it in Tokyo. We run the test. Good. You know Tokyo is a location. So we try another one. We clear the text box. What day is it on Friday? We run the test. Perfect. You know it is weekday date. We can try other as well. So we are ready, and we try to use another one. For example, I want to ask, what's the day on Wednesday? We run the test. Perfect. Another one, what day was January 1st, 2020? Perfect. The last one, what day will March 7, 2030 be? Run the test. Perfect. So we can move forward to use the model from a client application. In a real project, you will refine intents and entries, retrain and retest until you are satisfied with the predicted performance. Then, after you are satisfied with the predictive performance, you will test it and test it again. You can use it in a client application by calling its REST interface or a runtime specific SDK. So how to do it? Let's go to the Visual Studio. We'll click Start to open the Visual Studio code. I will develop a language understanding application using VS Code. The code file for the app has been provided in a GitHub repository. So the first one is we want to get it from the GitHub, right? So we go to git clone and we type the URL for the repository. We clone it from the repository to a local folder, download folder as the local repository location. Oh, that says error. Okay, cool. Let's show the command. This is a get error. Okay, so sometimes it is an error, but it is good, so we can troubleshoot. We select the git clone again and clone from GitHub, and we provide the location. Hit enter. That is this in the download. Clone it again. Now, this time it is successful. We open it and we go to left file. This is the first one language. We go to Python. Then we have a two language for us to select. We'll using Python as a sample. So in the code intent file, we will open in integrated terminal. Firstly, we will, in the Python, we will set up SDK. Install the Azure AI Language Conversational Language Understanding SDK package by running the appropriate command for Python. The command is pip install Azure AI Language Conversations. Install the SDK. Do you remember the next one? If this is completed, okay, this is completed. We need to go to environment to change the endpoint and the key. So let's move it back to here. We go to the resource. Firstly, you show the endpoint and keys here. We copy the endpoint and paste it here. Endpoint. And we go back and copy the key as well and paste the key here. It's safe. Let's save it. Now we are ready to add the code to the application. We go to the Python code. The first is we go to the import namespace. Here, we'll import the namespace by typing following. Import the namespace. And later on in the main function, we loaded the code to load the petition endpoint and key from the configuration file has already been provided. Then we find the command create account for the language service model. And add a code to create a petition card for your language service app. Below the code is ready there. So we go to the main function, okay? Get account for the language service model. Here, get account for language service model. We type the URL endpoint, Azure key credentials, and deploy the conversational analysis kind to the endpoint and credential. But make sure what you are doing right now is for the Python code, okay? So let's do it again. We create it, and the can is conversational can. Petition endpoint, Azure key credential is petition key. Okay. The next one is called the language model to get intent and entity. So let's continue. We add the Python code here. We have the CL project, clock, deployment slot, production. With can. Jewelry, user test. Result equal to can analyze conversation. Pass. Time. Analyze. Conversation. Partition ID. ID. Modality. Language. Test. Is login enable false? Parameters. Project name. Deployment name. Purpose. The next one is top intent. Result equal to result entity. Result. We start to print it by print it. Print it. Print it. Okay, then the call to the language service model return a prediction result, which include the top most likely intent, as well as any entities that were detected in the input utterances. Let's do it again. Repeat again. The call to the language service model return a predict result, which include the top intent as well as entities that were detected in the input utterance. Your current application must allow you that prediction to determine and perform the appropriate action. So the last one is we apply the appropriate action. How to do it? So we will add the following code, which checks for intent support by the application get type, get date, and get date, and determine if any relevant entities has been detected before calling an existing function to produce an appropriate response. So we'll go to the Python code here, and we'll add the Python code to apply the appropriate action. Let's get started. If token get type location local, check the entities. If land entities larger than CFO, get the type for the specific location, and it get type location. Else, if top intent equal to get date, data stream, date.today stream type, check for date entity to check it, and later on we get the date for the specific date. Else, if top intent equal to get date, so we'll do another action to print the date. Else is for some other intent was predict, print asking me for the item, the date, or the date. So let's save the change and move to the integrated terminal and run the program. Also, it can run on log, but let's try to see the start is success or not. If not, we will go for troubleshooting. Okay, we enter some text and say hello. We can say what type is it. We can say what's the time in London. We can say what's the date. Learn perfectly, right? What day is Sunday? What day is it? What day is January 1st, 2025? Oh, Wednesday. Correct. The logic in the application is simple and has a number of limitations. For example, when getting the time, only a restricted set of cities is supported and daylight saving time is allowed. The goal is to see an example of a typical pattern for using language service in which your application must connect to a prediction endpoint, submit an annotations to get a prediction, implement logic to respond appropriately to the predicted intent and entities. Now, we are able to keep it quick because we have finished the testing. Well done. We have already learned how to build an NLP CLU model, leverage Azure AI service. I'll see you in the next session. Bye-bye.